So in this question, we're working on the lifetime of batteries, which follow a normal distribution with a mean of 18 and a standard deviation of 4 hours. Alice's calculator needs 4 batteries and will stop working if any of the batteries reaches the end of its lifetime. We want to find the probability that a randomly selected battery lasts for longer than 16 hours. So the probability that L is greater than or equal to 16, straight into our calculator, answer of 0.6914. Okay, so next we're told that Alice has put 4 new batteries into her calculator and has used them for 16 hours, but still has another 4 hours of her exam to sit. Find the probability that her calculator will not stop working for the remainder of her exams. Okay, so this will be a given probability, and we want to find the probability that the battery lasts for longer than 20 hours, given that it's already lasted for longer than 16 hours. Okay, we should know the form that this is going to take, but quickly on a diagram, this is what we're looking for. Since I already know it's lasted more than 16, just out of this probability, I want to calculate the probability that it lasts for 20 or longer. So that's this darkly shaded area out of the total shaded area. Mathematically, that's the probability that it lasts for longer than 20 hours over the probability that it lasts for over 16 hours. All right, so both of these we can put into our calculator, put it all at once as a fraction, and that gives us the answer of 0.44621. Now, that's the probability for a single battery to last for longer than 20 hours, and I need that to happen on all 4 of the batteries. So I'll take that probability and raise it to the power of 4, and that will leave us with 0.03964, and that's the probability that all 4 batteries are going to last the total 20 hours. All right, so the 16 hours, we already know it lasted, and there's an extra 4 to cover the exam. All 4 batteries lasting for 20 hours. Okay, so in part C, we're thinking of a slightly different situation. If Alice was to change 2 of her batteries, so 2 new batteries, and 2 of the batteries that have been going for 16 hours already, so 2 older batteries, what's the probability that her calculator will continue to work fully? And since this is a show that question, we're trying to show that that probability equals 0.199. Well, the 2 new batteries, I'm going to calculate the probability that a battery lasts for longer than 4 hours and square it for the 2 batteries and multiply that by the probability we'd already found, the conditional probability, and square that for the 2 batteries. Okay, so just into the calculator to quickly find the probability of greater than 4 hours. And this whole calculation can also go into the calculator. And that gets us 0.199. So in this part, we've been asked to conduct a hypothesis test on Alice's belief. She believes that the lifetime of the batteries are more than 18 hours. So our null hypothesis mu equals 18, and the alternate hypothesis mu is greater than 18. Let's get the distribution for the population down. So L followed a normal distribution with a mean of 18 and standard deviation of 4. Since we're taking a sample of size 20, the distribution of the sample mean is going to have a mean of 18, but this time around, the standard deviation is going to be 4 over root 20. Okay, we observed 19.2 hours as a mean lifetime for this sample, and the probability that the mean lifetime is greater than 19.2, we can work out on our calculators with the parameters that we've written, and that comes out to be 0.089856. Okay, a comparison to draw a conclusion. This probability is greater than the significance level, so there is not enough evidence to reject H0. If we don't have enough evidence to reject H0, then there is evidence to suggest the lifetime of batteries is actually 18 hours as earlier stated.